Have you ever wondered why our planet has experienced periods of intense cold called ice ages? Let's embark on a journey through time to unravel this mystery. Our planet, in its billions of years of existence, has experienced a series of ice ages. But what exactly is an ice age? Well, it's a prolonged period of cooling on Earth. This cooling leads to the expansion of ice sheets and glaciers, turning vast landscapes into icy wildernesses. Imagine a world where mammoths roam and the ground underfoot is frozen solid. A world where ice reigns supreme. But Earth is a planet of cycles. Just as day turns into night and seasons change from spring to summer, autumn and winter, the Earth cycles between ice ages and warmer periods. These warmer periods, my friends, are known as interglacials. Now, you might be surprised to learn that we are in fact living in an ice age right now. Yes, you heard that right. The current ice age is called the Quaternary glaciation. Although we are in a warmer interglacial period, the overall ice age has not ended. The vast ice sheets of Antarctica and Greenland are remnants of this ongoing ice age, a testament to the Earth's ever-changing climate. The concept of ice ages wasn't always accepted as it is today. It was developed in the 18th and 19th centuries by various scientists. These scientists dared to challenge the status quo and proposed a theory that was met with skepticism. But as time passed and more evidence was gathered, the theory of ice ages gained acceptance. It is now an integral part of our understanding of Earth's history. So the ice ages are not just a figment of Hollywood's imagination, but a real and fascinating part of Earth's history. This journey is just beginning. Stay with us as we delve deeper into the enigma of the ice ages. But who were the sharp minds that first proposed the idea of ice ages? Well, let's take a trip back in time to the 18th and 19th centuries, when the concept of ice ages was just beginning to take shape. The theory of ice ages was born out of the keen observations and intellectual curiosity of a few pioneering scientists. One of these was Pierre Martel, an explorer and naturalist. During a trip to the Alps in the mid-18th century, Martel noticed the presence of large boulders in places where they seemed out of place. This observation led him to propose that these boulders had been transported by glaciers, hinting at a time when glaciers may have been far more expansive. Next, we have James Hutton, often hailed as the father of modern geology. Hutton's work in the late 18th century laid the foundation for the understanding of Earth's deep time and its constant state of formation and transformation. He proposed that the Earth had gone through cycles of geological change, and these cycles could include periods of intense cold or ice ages. Finally, let's talk about Louis Agassiz, a Swiss-American biologist and geologist. Agassiz was a major advocate for the Ice Age theory in the mid-19th century. His extensive research and fieldwork led him to conclude that the Earth had experienced a past Ice Age. Agassiz's work was instrumental in bringing the Ice Age theory into the mainstream scientific discourse. It's important to remember, though, that these ideas were not immediately embraced by the scientific community. The Ice Age theory was met with skepticism and was considered quite radical at the time. It challenged the traditional understanding of Earth's history and required a rethinking of established geological theories. However, these three scientists and others who followed in their footsteps persisted in their research and argumentation. They collected evidence, conducted experiments, and refined their theories. Over time, they managed to convince their peers of the validity of the Ice Age theory. These scientists laid the groundwork for our understanding of ice ages, despite initial skepticism. Their work has profoundly shaped our perspective on Earth's dynamic and ever-changing climate. How did a theory that was initially met with doubt gain acceptance? This question brings us to the heart of our third act, the overcoming of skepticism. The Ice Age theory was not always as widely accepted as it is today. It faced considerable opposition when it was first proposed. Let's delve into this fascinating journey from doubt to acceptance. Picture this, it's the mid-18th century and a revolutionary idea is being proposed. An idea that asserts our planet had once been consumed by ice, a concept far removed from the understanding of the time. This was the Ice Age theory, and it was met with profound skepticism. Why, you ask? Well, the idea of a world covered in ice was a far cry from the tropical climates and temperate zones that were familiar to scientists of the day. Enter James Kroll, a man who would play a pivotal role in shifting this skepticism. Kroll was a self-taught scientist whose curiosity led him to explore the concept of ice ages. He proposed that variations in Earth's orbit and axial tilt could have caused the cyclical periods of cooling, leading to the expansion of ice sheets and glaciers. Kroll's work was groundbreaking, and it laid the groundwork for further research into the Ice Age theory. But acceptance wasn't immediate. The scientific community is, by nature, cautious and critical. They questioned, probed, and challenged Kroll's work, as they should, but as the evidence piled up, the skepticism began to thaw. More and more scientists started to see the value in Kroll's work, and the Ice Age theory started to gain traction. By the late 19th century, the theory had gained wide acceptance, proving that even the coldest of skeptics could be warmed by the heat of undeniable evidence. Our journey from skepticism to acceptance is a powerful reminder that in the world of science, perseverance is key. It's about pushing boundaries, challenging the status quo, and never giving up in the face of doubt. The acceptance of the Ice Age theory is a testament to the power of science and perseverance. This statement is not just a tribute to the Ice Age theory, but to every scientific theory that has faced skepticism and emerged victorious. But why should we care about these periods of intense cold, you may ask? Well, the Ice Ages have had a profound impact on our planet in ways you might not expect. Let's start with the Earth's climate. During an Ice Age, vast sheets of ice spread across the land, reflecting sunlight back into space and cooling the planet. This process, known as albedo, can dramatically alter global weather patterns, contributing to colder winters and cooler summers. These climatic changes can last for tens of thousands of years, shaping the course of the life on Earth. Now, onto geography. The weight and movement of ice during these periods can carve out valleys, create lakes, and reshape entire continents. The Great Lakes in North America, for instance, were formed by glacial erosion during the last ice age. So the very ground beneath our feet, the mountains we admire, and the valleys we traverse owe their existence to these icy epochs. And let's not forget about the species. Ice ages have played a pivotal role in the evolution and distribution of life on Earth. They've driven the evolution of cold-adapted species, prompted mass migrations, and even caused extinctions. The woolly mammoth, for example, evolved to survive in the harsh conditions of the Ice Age, but went extinct as the ice retreated. Understanding Ice Ages isn't just about unraveling the past. It's also about predicting the future. By studying these periods of intense cold, we can gain insights into how our climate might change in the future. This can help us prepare for and mitigate the effects of global warming. So, Ice Ages are more than just a fascinating chapter in Earth's history. They've shaped our climate, geography, and the very life that inhabits our planet. The Ice Ages have left an indelible mark on our planet, shaping the world as we know it. So, what have we learned about these fascinating periods of intense cold? Ice ages, these prolonged periods of cooling on Earth, are not just about a chilly atmosphere and expanding ice sheets. They are about the cycles of our planet, the dance between cold and warmth, between ice ages and interglacials. The current ice age, known as the Quaternary Glaciation, is just one of the many chapters in Earth's compelling narrative. The concept of ice ages was a puzzle, a mystery that intrigued the minds of scientists in the 18th and 19th centuries. Pierre Martel, James Hutton, and Louis Agassiz were among the pioneers who dared to propose this theory. They painted a picture of a world not static but dynamic and changing. Like any revolutionary idea, the theory of ice ages was met with skepticism. But the resilience and determination of these scientists, like the ice they studied, stood firm. James Kroll, through his meticulous work, helped the scientific community and the world at large to accept the reality of these cold epochs. Ice ages have had a profound impact on our planet. They have carved landscapes, driven the evolution and extinction of species, and influenced climate patterns. But their significance goes beyond that. They serve as a window into Earth's past, a lens through which we can glimpse the mechanisms that drive our planet's climate. In understanding ice ages, we don't just learn about the past. We gain insights into the present and possibly the future. They remind us of our planet's resilience, its ability to adapt and change. They also warn us of our responsibility as the inhabitants of this planet to understand and respect these natural processes. As we delve deeper into the mysteries of our planet, the Ice Ages continue to offer fascinating insights into Earth's past, present, and possibly future.